Okay, well after a fair amount of travelling about that stopped me actually sitting down and actually really playing with this little LED moving head disco light, I'm finally now able to actually sit down, play with it and give you, a look inside it. So you'll notice that you've got a slightly wider view. In fact, you're seeing the masking tape here that I usually mark off the area to try and stay in when I'm actually filming things. And you'll also notice that I've got automatic exposure on, which means that my hands are going to wash out white, but that's because this is matte black, as disco lights often are, and this is the subject we're going to be looking at. So let's take a look at it. It's got a Euro connector mains in, it's got a little fan, a noisy little fan, a crumpled up label which didn't quite fit under the cover apparently, and it's got 3-pin DMX in, DMX out. On the front it's got the very, very generic Chinese disco light, 4 buttons, 4 LED displays. Now I say generic Chinese, to be honest that's fairly generic disco light full stop. Even the big theatre lights like Vari-Lights, although they've got an LCD display, they still use the standard configuration of menu, up, down and enter. It's also got this little Lixada label which had been stuck on. It's a generic branded LED light. It's just, they must just relabel it as desired. And the Lixada label had been stuck on over the protective film. So when you peeled the protective film off came the brand as well. So Lixada by name, but generic Chinese by nature. So let's plug this in and I'll show you initializing and then we'll go over the details. So I'll plug it in and the first thing it does is it finds its default position, and you'll hear a micro switch go click shortly. I like that, just the way that little click happens. And then because it's not getting DMX, it will go into automatic mode and make sort of loud stepper motory sort of squishy noises as it pans about and randomly changes the gobo in colour. So I'm going to plug the DMX in now and it will suddenly violently react by going to the program position. Yeah, that's quite fast, and to give you an idea of how fast it can go, yeah, it's really quite, it can thrash about quite a thing, but when you really thrashed about, it is possible to make it cog on the stepper motor. You can actually hear it skip a phase in the stepper motor, but it's kind of rare it happens, and when it comes to crunch you can set one of the settings. Let me see, what is it, where is it? Oh, pan tilt speed, it's setting 7, and you can actually change the speed at which it will pan for nice smooth sweeps. And that's me, say that's me sliding the pan and tilt up to maximum minimum. It does so at a controlled speed that you can set. So let's see, what's the best thing to do here? The best thing to do is show you the features available. So I'll just slide that out of the way. Now, things worthy of note. The power of it draws 40 watts. It says in the manual it draws 25 watts, but it actually draws 40. So let's bring these in. The LED it says is 10 watt. I checked it out, and when the LED is on and off, the difference in power consumption of the fixture is 8 watts. So let's say an 8 watt fixture. The LED heatsink runs about 40 degrees centigrade above ambient, which is quite good. So the unit is configurable in either 9 or 11 channel mode. In 9 channel mode on the DMX, you've got pan, tilt, colour, gobo, shutter, dimmer, pan and tilt speed, and the control channel, which lets you select various control functions including resetting the light remotely. Or you can also do things like you can tell it that when it's moving it should close the shutter or turn the LED off, or when it's changing colour or gobo it can do that. So it's just a few useful little features. And the final one is odd, it's a dimmer characteristic which I've got set to just standard default. Let's turn this off at the moment because it's quite, it's got a noisy little fan. So the dimmer characteristic does the things like, tungsten emulation, TV studio, linear. It's quite an odd that they included that. If you go up to the 11 channel mode, all it does is add 2 more functions in, pan coarse and pan fine, and tilt coarse and tilt fine. And to be honest, the resolution and intensity of this light is such that you're not going to ever really need fine, pan and tilt, because I don't think it's, it's pretty repeatable, but I don't see many people really having an application for that, but it is there if you want it. When you go into the menu mode, and it's worth noting that to go into the menu, I'll just unplug this cable here. When you use the button to select menu, it comes up with these in sequence. You can then click up and down them. And these are as they appear in the display, and this is one of the least clear bits of the thing. ADDR is reasonable enough. It's the DMX address from 1 to 512, which is pretty pointless going right up to 512, but I think it's using fairly generic software that probably allows for single channel use. What happens in the DMX is you've got 512 addresses, but say in the case of the 9-channel mode, if you select address 1, it will then assign these channels in sequence after that. So these would literally be addresses 1, 2, 3, 4, 5, 6, 7, 8, 9. And likewise, if you set it to address 10, then pan would be at 10, tilt 11, color 12, and it would just go up from that point. So being able to set it, I'm not sure what would happen if you set it at 512. I don't know if it would show an error or not. I've not tried that. Maybe I will later on. The next mode, CHND, is the number of channels, and you can just select, using the up-down key, you can select 9 or 11. SHND is the automatic show that it will do in response to the audio. Now this ranges from just slow sweeps around to just sort of pointing down just very small restrictive movement and the sort of colours it will go through. You get to choose between 0 to 4. Dimmed is the dimmer mode. You can that's the equivalent of the dimmer characteristic, but you can set the style of the dimmer on the actual fixture. SLND is when it's being used in master and slave mode. You can either select master mode, where one of the fixtures will be set to a master, connected via the DMX network but without the lighting desk. And as long as all the other fixtures, there's only one master and all the other fixtures are set to the same slave address, say slave 1 or slave 2, then they'll all run in sync. Sound. That means sound mode on and off. It's got a built-in microphone, and if you turn it on, it reacts to sound, but only when there's no DMX. DMX seems to take priority and will just turn off the automatic features. Sense is audio sensitivity. That lets you choose between 0 to 100 for how sensitive the microphone's going to be. This is nice. Pint, it gives you a pint of beer. No, it doesn't. Pint, Pint is pan and reverse. Pan reverse, so you can actually have the pan going either default left or right, and it's nice being able to reverse that. Tint is tilt reverse. LED display on and off. What that means is that after a default time, the display will go to just displaying the DMX number, but you can choose that at that point it will go off instead, which is useful where you don't want people seeing the sort of light, the digital displays in the grid, in the rig. Disp, it's interesting, this one. It says in the manual, the very Chinglish manual, it says, Disp display, please user no set it. Okay, and it also says test, please user no set it. They don't want you messing about with that. I don't know if they got confused by the fact that display inverts the display, it tips it upside down, and the reason for this is that sometimes these lights are sitting down a stage, pointing up the way, and sometimes they're hung from a truss, pointing down the way, and it's quite normal to have the display invert feature, and as far as I can see it works. I don't know if they've just set that mode and then not worked out what's happened, because they're maybe not expecting the sort of English characters to go upside down, so to speak, and it's just confused them, but display invert does work. Test does a very violent self-test where it just suddenly shoots round to a random position, and then it just does various gobo and colour tests. Temp is LED temperature, and it seems quite accurate. It tallied up with my thermal imaging camera. And RSet is fixture reset. What that does, it's equivalent of unplugging, plugging the fixture. It will just make it reset to its default position and then go back to where the DMX was. And it's just lets you, if you've been doing something, you've nudged it and moved it about, it lets you just reset it there at the fixture from the keypad without having to unplug it, and that just resets it. So now that that's covered, I shall show you the gobos and colour. So I'm just going to pause while I set it up, because I'm going to have to hold it up and point at a sheet of paper on here. So I'll be back in a moment. Okay, so let's take a look at the colours and gobos. Now I'm holding this by hand, so it's going to be rocking about everywhere. I just don't have anything to hang it from. So colours, open white. It's a white LED with dichroic colours. Now incidentally they call them diachronic colours, which I think is just a great name for them. I think I'll refer to dichroic glass as diachronic glass from now on. So starting off with red, and to be honest, the iPad doesn't render this very brightly. Which is a shame because it's actually quite a bright, rich red. Cyan comes up well. Orange is good. All the colours are good actually. Deep blue, well bright blue actually. Yellow. Green. And pink. So it's got effectively 7 colours plus white. And then it's got the, it can pan through them itself. Now, as you'll see later on, the colour wheel doesn't have 360 degree rotation as such. It's got an end stop for initialization. So that means that it will sort of, when it gets to the end of the colours, it has to swirl right through back them all. So now let's take a look at the gobos. And I'll try and get this in focus. So gobo 1, gobo 2, open, 3, 4, 5, 6, 7, and then it will do gobo shake, which is a great effect actually. I like gobo shake. I've always kind of been fond of this, just as for a sort of nightclubby environment. It just gives a good vibrating light in the air effect. Maybe not showing up so well on the iPad, but it's yeah, it's not bad. And of course it can go through the gobos, it can scroll through itself and go back to the start again. So that's what the gobos and colours look like. Okay, now it's the fun bit. Now we get to take it to bits. And I'm going to leave the camera in automatic exposure again for this because, as I say, it's a jet black light. It's not very photogenic if I try to lock the exposure off. So let's take some screws out. Let's use the correct screwdriver, shall we? That isn't the correct screwdriver either, but that's alright. So let's whip the covers off this. I have to say, it's not something I'd use in a big theatre or a concert, or, well, if it was a small concert, but certainly for nightclub use, it's actually really impressive. It's got very well defined beams. The focusing is done manually from the front. It's fixed focus. But once you've got it focused, it cuts the air nicely. If you've got a bit of haze in the air, it actually is really surprising for a fixture rated at just, with just a 10 watt, well, 8 watt LED. So let's pop this cover off. And indeed let's pop the other one off the other side as well. So we've got complete access for our carnage. It's got a very robust metal chassis with the plastic panels screwed on. It looks quite robotic when you take them off, as you'll see. I like it a lot. If you hear a beeping, squeaking noise in the background, it's because my tumble dryer is running in the background and it squeaks. It just has these little bursts of squeaking every so often. I got absolutely drenched today. That's the work clothing is in the tumble dryer drying off. So 4 screws hold each of these cheeks on. I shall put the screws in these cheeks. I do notice that it's a bit of a mixture of screws. I'm not sure why that is. A bit random. So, looking inside, we have the gobo wheel here, which has an end stop. So the stepper motor, well, let's actually power it up. And am I going to be able to show you this going if I power it up? The only place there's mains voltage is in the base of these fixtures, these particular, the LED ones. Well, to the best of my knowledge. You can see the gobo wheels are hitting their end stops, gobo and colour, and then initializing. Yeah. Hold on, let's see that from scratch. So they go around in a slightly sort of steppy, jumpy manner, but that's obviously happening in the software that's deliberately doing that, to just incrementing the round sections. Okay, reasonable enough. Now, these assemblies seem to come out Let's see if I can whip them out then. This motor does have a plug in it. Oh, they do just unplug, that's nice. Very modular. Does the lens screw all the way out? Yep, you can take the lens out for cleaning, that's quite handy. The lens assembly is screwed in from that side. This whole front piece comes off. I don't need to take it off, but you know what? I'm going to take it off. Oh wait, no, you know what? The hardware isn't that captive in the back, so maybe I'm not going to take that off. Let's take this little stepper motor out then. We'll take the dichroic motor out. The diachronic motor. It's very modular. I get the feeling that there's a lot of similar fixtures that just use the similar components. So this comes up like that, and that little plug will come out the side of that. I might not get it back in again afterwards. And you can take the whole dicroic, the diachronic disc out. That's quite neat. I wonder if that's a really standard motor. It probably is. Likewise, the whole front plate of this comes off. Oh, you know what? I can take that off, can I? You know, if the hardware isn't captive, it's not captive. Let's pop that plug off. Pop this screw out. Yeah, actually, you know what? That's not captive, so it's all going to end up just dropping inside, and it's going to be quite hard to put back on again. Anyway, the LED. The LED has a... Now, how am I going to get that off? Oh, I know. The LED has a connector on it which has 4 connections. I'm guessing they're just doubling up on the positive and negative to the LED just for current, because it's going to be fairly high current. It would have been nice to lock the iPad off in colour temperature. I really should try other camera packages with it just to see if I can get a version that does that. It's just never quite has all the features I want. Maybe I'm just too demanding. I should mention there's passive cooling for the LED in this. It's strictly, you know, it's strictly a passive heatsink. There's no fan in the head itself, which is good, which means the LED is effectively sealed inside, and it should stay fairly clean. Now, I would take this out further, but there's 2 little wires going in here that are not easily removed. So let's remove the lens from the LED, and this is where I'll let you guys identify the LED. It's probably a very standard format, might possibly be a Cree, I'm not 100% sure. I'm not even sure if the little circuit board it's on is a very standard format. If it is, that does allude to the possibility that you could change the LED. So it's a single LED, it's small. These wires are just tacked across a thermistor, which you can unplug it. You can unplug it down in the board, but not up locally, which is a bit disappointing. So yeah, small LED that you guys probably can't see. I could try bringing it up, but I don't know if it's going to actually compensate for... Oh, there you go. So, a fairly standard looking circuit board with a, you know, heatsink interface with the little sort of recess in the back of the, you know, the metal plate that holds the heatsink on. So quite nice. Oh, I'll actually put that in with a couple of screws at the moment just to hold it in place, because I'm going to be taking more to bits. So let's just roughly reassemble that. Now we'll take the yokes off. Now typically in a big high profile moving light, the yoke covers would cover the tilt motor, which I think it does in this one, and the lamp driver, which is the LED lamp driver in here. So let's take them off. One screw, 2 screws, 3 screws. So It's nice and modular, and it is a really robust frame. So that comes off. Very much like a typical, you know, high-profile brand moving light, to be honest. Oh, there is circuitry in the yoke, so let's pop the other side off. One, two, three. Right, on this side we have what looks like a fairly generic LED driver, presumably with power coming up, plus maybe a control, a pulse width modulation signal. I'm not sure if that will be analog or digital. Possibly just digital pulse width modulation, and then the output. And they have just got the pair of red into one turn and pair in black, so that is just doubling up. This loom does the stepper motors, and there's also the two fine wires in there for the thermistor going down. This is rounded, this is soft, it's not going to cut into the cables. And likewise, the other side it's soft as well. And it's very robust, it's got a proper bearing, a ball bearing race to the look of it. And it's held on by circlips here, so that's pretty damn impressive actually. This is actually surprisingly well built. Now on the other side, we've got the tilt motor, which is a fairly small, fairly standard, you know, stepper motor. And it's driving via a timing belt onto the actual yoke. And the yoke has two limits. It's got the mechanical limits here, which hit end stops. Plus, it's got this little Hall effect sensor and a magnet glued in. And when that magnet comes round to that position, and they've just kind of bent the Hall effect sensor to the point that, you know, once it's reached its end position, they've obviously just nudged that over to the point it was just triggering, and that gives it its homing position for the tilt. I will say that one of the hottest components I've found so far in this is the tilt motor, which is odd because it does, even when you leave it static, that it obviously keeps it fully energized just to lock it in position. But the tilt motor measured about 60 degrees above ambient temperature, so you know it gets modest, it gets quite hot to touch. So let's take it to bits further, and this is where the base assembly splits into two halves, and again this is pretty much like a standard moving light fixture, moving head fixture. So these two screws come out the top, and then these ones at the corner come out underneath, and they're kind of tapped into the plastic. And that lets that cover come off. I shall try and keep these things together for reassembling it. And I'll take the other side off as well. One screw, two screws. When I put this back together, I will also put that label under in the correct place because it looks ugly. I'm liking the fact it's got a screw underneath here with the earth symbol next to it. I wonder if there is actually an earth connected to it. And off comes that. Let's keep these screws with the appropriate components. I will lose them at some point. Oh, that's worth mentioning. Where is it? Lots of screws holding this together. Yeah. When I first got this, there was a screw rattling loose, and it was one of these ones. There are four that hold this sort of assembly. It allows it to slide up and down to tension the belt. One of them was missing, loose, and I tried screwing it in, it was stripped, so yeah, loses a little point for that, but wins everywhere else. Look at the size of strangely enough, I would have thought. You know, it just seems that this motor just, is this bigger than the other one? It looks so much bigger. Yeah, I'm pretty sure that's a bigger motor than for the pan. And it's really robust. Again, it's got the drive belt, it's got the slipping actuator here that actuates that switch there. The little switch down here that gives it its home position. And that actuator also slides round within a sort of margin underneath the yoke itself, so that it's got more than 360-degree rotation, so that, you know, it catches that, and then when it spins round the opposite direction, it spins almost a whole revolution before catching that. It's neat. It's very modular. It's got the mains coming in, which then goes straight onto a connector on this power supply circuit board. And on the other side, it's got a connector coming off with 4 wires. I'm not sure if that's 12 and 5 volts. It may actually be more than 12 volts. So let's try and get some more apart here. Oh, where's the earth wire? The earth wire may actually be connected. It looks like there is a lug on the earth wire in here. Yes, there is. That's nice. So let's see what more I can take out here. Let's try taking the whole mechanical assembly. Oh, you know what? I could take the end cheeks off. That would, are these going to come off? Yes, they are. That would give interesting access. As I say, I didn't know what to expect when I bought this. I am really surprised how robust it is, which is good. That's always good. And the quality of the bearings and things like that, because although it's a fairly light little light, it does seem to be quite robustly made. Now this is where I have to actually maybe ponder marking these connectors before taking them off. Let's get the power supply connector off. That's fairly... I think it might be time to pull out the camera and take a picture before I go too much further, because there's lots of very similar connectors here. Now these two are the red and black. They're two very similar connectors with similar colour cables, and I'm not sure what they're actually going to, so I'm just going to take a wee picture of that before I go any further. Camera. Always take pictures as you go. Because, yeah, the last thing I want to do is take it to bits and then forget where everything went. So let's pull this off for a start. That's going to give modest access. Does the power supply come out easily? The power supply does come out easily. Let's see how easy it is to change the power supply. The power supply is screwed in from the top. I should be able to just pull off that connector with maybe a little bit of tweaking. Try not to pull the wires right out it. Oh, maybe not. Oh, I'm not sure which way that little clip's supposed to squeeze. I shall get my finger down there and try and squeeze it. There we go. It's the mains connector off. So let's get the power supply out, which has a little LED in it, which is nice as well, a little indicator LED. Looks a fairly decent little power supply as well. Obviously you can't really tell just how good it is until you know the light's been sitting in a rig working for a while. I couldn't tell you how long these are going to last, these lights. You just never know what could fail, but so far it looks pretty impressive. The only bit that is that slightly squirmy is the temperature of that little motor. it's reassuring to know that it's not that hard to change the power supply. Yeah, that's the power supply out. That's nice and modular. God, you know, I wish it was as easy to change the VL3000's power supply. That would definitely have been a revelation. Actually, I'm talking about the VL lamps power supply, which is just a nightmare, the VL3000. The separation is actually quite interesting in here. It does look like they've made a real effort to separate it with the little interference suppression capacitor here. A note about these little capacitors that you see connected, the class Y capacitors connected between the secondary side and the primary. When you've got a high frequency switching power supply, the transformer, although it's designed to couple across inductively, also couples across capacitively because it's running at very high frequency, so though there's a very low capacitance between the windings, the primary and secondary, it's still enough to actually transfer a modest amount of current across. And without any easy path for that to return, it tends to find routes along other cables, and it can cause radio interference. As a result, it basically acts, any wiring attached acts like an antenna for the high frequency switching noise. So that's why they put this little capacitor here. It basically provides an easy return path for that leakage, capacitive leakage current through that, back to this grounded reference side, and it cuts down the interference that way. So yeah, it looks a reasonable enough little power supply, I have to say. Looks reasonable enough indeed. Maybe I should have discharged the capacitor on it before poking it about. Maybe I should poke that now. With a metal screwdriver, obviously. Yeah, that's discharged, maybe just as well. I'll give it the finger test as well, shall I? Yeah, it's discharged. Yep, neat. Easy to change the power supply, that's reassuring. Whether it's easy to source the power supplies is a completely different matter. Let's remove this whole assembly then. So this is held in by 4 screws. I should also mention this unit does come with a plate to mount it. You can see the holes here for hanging it from a truss. Well, I say you can see the holes, but of course it's jet black and it's trying to compensate for my very white hands. There's the hole there, so you couldn't see a thing. Oh, little skid mark in the base. That's its resale value diminished. It's not being resold. This is my toy. It's not going anywhere. Right. Okay. So, that connector there is going to the fan. I'm going to cut that wee tie wrap. Try not to cut wires while I'm cutting the cable tie. So this looks like the fan connector. Hopefully it says fan next to it. No, it doesn't. Oh well. No, I don't see any text next to it. I'll just have to remember that. This connector here is for the DMX interface. And suddenly that's out, and the earth pin is actually connected by this thin wire over to the earth hub. That's quite nice. So now we've got this big chunky stepper motor with its little the switch, incidentally, if the motor slams round and it goes beyond the switch, the next thing after the switch is a physical limit, so it will physically stall it. And I've not tried it yet to see if it will still initialize, if the switch isn't working, if something went wrong, if it'll actually just try and skip against the end, you know, when it goes round and then it can't find its switch and then it just sits and just shudders at the end and slipping in the motor. But that is really robust, isn't it? This is a huge machined bit. Again with the slip rings and the curved, it's pretty impressive actually. Now what about the drivers? Oh, they've scrubbed the numbers off. The knuts. The bastards. Yeah, okay, so these two little connectors here are obviously doing the two little tiny stepper motors, because they've got little stepper motor drivers there, identical ones. And the other side, and have they scrubbed the numbers off again? Look at the length of the cables, that's quite impressive. No, they've not. they've not scrubbed the numbers off. Let's have a wee gander at that. ULN 2803, oh my god. ULN 2803, standard Darlington drivers. So all the pulse and modulation, all the high frequency, to keep it, I think they're using wave drive, but those aren't wave drive chips, they're just standard Darlington chips. Really common Darlington chips, and they're 8-channel, but I can see from here that they've bridged pairs of outputs to make it 4-channel driver chips. They are just an off-the-shelf component. I'm so annoyed that they've rubbed the number off that chip over there. What's the processor? Am I going to be able to read the processor here? Let's see if I can read the processor. I may need to crack out the dinky little microscope for that one. It's quite tiny. Let's try it with the magnifying glass first. It's an ARM processor. STM32F something 03, it's not actually terribly clear. 303? Does that sound right? Not a lot in here, is there? STM, yeah, that's pretty hard to read. I'm going to crack get the microscope into that and take a wee look at it and just see if I can actually get any more details off it. Is this going to reveal more? No, this is one of these things that this little microscope has a cold white LED in it, and sometimes the colour of the cold white LED is not terribly friendly for showing up what's actually written in the, what you're actually looking at. Yeah, I can't get over the fact it's using ULN 2803s. I think that's great, because that's one of my favourite little driver chips. Oh, you know what? I'm not going to be able to read this off that. I shall do my best to read it, and I'll leave a note to say what it is, because it's actually proving it's tiny text and it's a wee bit dirty as well, so it's not really showing up. It's the usual case that during the processing and manufacturing it's got a bit grubby. So based around it's a single chip solution, that'll be driving everything, won't it? Is there much on the other side of the board? There's only one way to find out. Whip it off! So I wonder how hot those chips are going to get. I might actually just cobble it together and give them the finger test. Or use the thermal imaging camera, which would kind of make more sense, wouldn't it really? That would be that would be the sensible thing to do. So what's on the other side of the board? Not much. Buttons, microphone, LED display. I'll tell you what, let's remove that cover off that LED display. That shiny protective cover that's put on during manufacturing to stop it from contamination. That's better, nice matte display, although it is going behind a gloss cover. It does seem to have, it's got an infrared. There was a hole in the front, it seems to have an infrared sensor position. So you can change parameters by remote control, I guess. The microphone has a little 8-pin chip in the vicinity. I think we can reasonably assume that's going to be an op-amp with a little bit of support circuitry. Probably gain control from the chip, I'm guessing. Voltage regulator. Not sure. Oh, that chip's for driving the display. I really like some of the features in this. I love the fact that it's a ULN 2803, as I said, driving the stepper motors. That is really quite pleasing. I thought it was going to be something more complicated. I thought it was going to be some fancy wave drive control. 4HC164D. So it's a standard. Is that 74? I guess it must be. Oh yeah, it is 74HC164D. So it's a standard CMOS based TTLE type chip for driving the display. Yeah, and just a bit of power supply circuitry down here, and these chips with the numbers rubbed off, the bastards. But yeah, I like this. I really do like this. I'm going to have to give it a wee soak test and see how hot these chips get now. So yes, I'll leave a wee note in that in the comments down below. So this one came from TomTop, and it was called a Lixada fixture. I think that might just be their labelling, but it's definitely, it's a toy. Oh, and they misdeclared the customs value, so it didn't get, it came by a courier, I think. It came through quite quickly, but the value was declared down, so that was quite nice as well. That was a desirable thing. It saves any delays in customs handling. But yeah, it's a good toy. I like it a lot. Okay, slight correction to make. I made the rash assumption that the small chips here, the ones the numbers rubbed off, would be driving the small motors because they had small connectors, and the big ones would have been driving the big motors, the big connections. And I was thinking, that's quite complex because, you know, the big step motors are being driven in wave. It's almost as if they're being driven by a proper step motor driver, which is what these probably are. So here we go. We could probably guess what these are if MD's into their stepper motor driver chips. I can tell you how many pins it's got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's a 28 pin chip, and it's notable that there's a clump of 1, 2, 3, 4, 5 pins in one corner. Trying to work out which orientation this chip is. Yeah, I'm not 100% sure. I don't know if they're the last pins in the chip. Yeah, I think it's round about the pin 28. There's a clump of 5 pins common together, definitely a sort of power rail. And that's what's being used to wave drive. And of course, the ULN 2803 is driving these little dinky stepper motors, and that's perfect. That's why they were going around quite jumpily, because it was just driving them in pulses. The processor is a bit of a beast. It's a monster. It's an STM32F103 R8T6. Fast processor with a lot of memory built in. That's really surprising. It's quite a monster, actually. Looking at that now, I'm guessing that little chip there may actually be the driver for the 5176B. Is that 7? I think it's something like that. That looks like the driver for the network, the RS485 driver for the DMX, I'm guessing. With what looks like a couple of protection diodes on it as well, possibly. Yeah, you know what? This has obviously evolved over time. It's actually quite a neat little unit. It's very neat indeed. I'm impressed. I'm actually impressed that it seems stable and it seems to have a decent set of functions. I will say there was one quirk when I was playing about with it. If you set the position and you had a fairly long throw and then you adjusted the colour or gobo, the actual pan and tilt just nudged just a fraction, as if it was just going in 1 microstep. And I don't know if that's just because the processor was just forgetting about the driver momentarily because it was concentrating on other things being driven, or whether it's a little bug that, you know, some common file was just nudging that. But it's no great deal for the application it's designed for. It's not a significant factor. So yeah, you know what? It's definitely a nice little light. A little update, because I did a little bit of detective work. I thought, what's the most common step motor chips that would be used in things like Arduino type stuff and, you know, things like 3D printers? So I just looked for common chips, and I thought that the common pins at the end were a common ground, but though it is ground, it's actually mode setting pins. But I found this pin, 28 pin chip, and the pinout roughly matched this, so I printed off this data sheet and then probed it out, and it does appear to be a DRV8824 by Texas Instruments. The little chip here is the RS485 driver for the DMX. It's a Texas Instrument chip as well, and there's also one other chip here which is appears to be a memory chip for the processor, so a serial memory chip. So yeah, it's pretty down-to-earth design. It's all fairly standard stuff. A common 78M05 voltage regulator and a small 3.3 volt regulator for the processor. It's all very standard and functional. Yeah, very neat. Now I just have to put it together again. No problemo. And that's it, back together and just the plastic trims to go on. Now, I did notice some other interesting things. I took some measurements. The power supply is putting out 24 volts and 12 volts. The 24 volts will be powering the stepper motors. The 12 volts will be powering the fan and supplying the voltage regulators for the other circuitry, like the 5 volt and 3.3 volt supply. The temperature of the stepper motor driver chips in here, I used the thermal imaging camera on them, and I found the temperature wavered between about 80 to 100 degrees centigrade, which sounds quite hot, but when you look up the data on the chip, it says that the chips are rated normally to, the maximum temperature is about, a junction temperature is about 150, 160 degrees centigrade, so I suppose that's ultimately in their range. Also, once I put the lid on, the air flowing through this unit will actually probably help cool those, I should think, because it is kind of in its path. So, yes, yep. Neat toy indeed.